In this video, we are going to discuss the notion of even and odd functions. So what is an even function? What is an odd function? So f of x is an even function, okay, if f of negative x equals f of x. Okay, this means this has a geometric interpretation. This means that the graph of f, well, the graph is symmetric about the y-axis. Okay. And then the definition of odd function. It's very similar. We just need to be careful because there is one extra negative sign. So f of negative x equals minus f of x. Okay, in this case, the graph is rotationally symmetric about the origin. About the origin. Okay, so let's see some examples. Here, the key point in these definitions are these formulas here, the ones unboxing. F of negative x equals f of x, or f of negative x equals negative f of x. Okay, those are the ones we actually use as a definition. So let's see some easy examples. For instance, f of x equals x squared, f of x equals cosine of x, f of x equals x to the power 3, f of x equals sine of x. Pause the video for a moment and see what you think, if these are even or odd. Okay, so for f of x, actually these, we know the graphs, right? It's a parabola. F of x equals x squared. Okay, this one is even. Okay, and that is easy to check because f of negative x is negative x squared, which is equal to x squared, which is f of x. So the definition works out. Okay, so that one is even. For the same reason, well, for the same reason or quite the opposite, x to the power 3 is odd. Okay, this is the graph of x to the power 3. This one is odd. You see that it is rotationally symmetric about the origin here. So the first one, actually, I didn't mention, but I will mention now. It's symmetric respect to the y-axis. The second one is symmetric respect to the origin. Okay. So now, is this one odd or not? So f of negative x, that is minus x to the power 3. So that means negative 1 to the power 3 times x to the power 3. So negative 1 to the power 3 is negative 1. So this is minus x to the power 3. That's minus f of x. So the definition is satisfied, so it is an odd function. And now the two that are left are the cosine of x and the sine of x. So the cosine looks something like this. Okay, there is a symmetry. respect to the y-axis, and on the other hand, for the sine looks like this. This is the cosine of x, this is the sine of x. In the case of the cosine, we have a symmetry about the origin. Okay, so in these cases, you can check that the first one, the cosine, is even, and the second one is odd. Okay, here you just need to check that the cosine of negative x equals the cosine of x, and the sine of negative x is negative sine of x. Check that in the trigonometric circle.